A number of you seem to be struggling with the concept related to the empirical rule. The empirical rule applies to any bell-shaped distribution, and it just gives us some insight into how much data or what percentage of the data falls within a specified number of standard deviations. Remember, the standard deviation is a measure of spread, and it just talks about how different the data values are from one another. You compare each individual data point to the mean or the average and perform some calculations, and that gives you an idea of how much the data varies or how much they're different. And the empirical rule just gives us some insight into what percentage of data should fall within that particular into a particular range. And so it's basically three values. The first one says that there are approximately 68% of all data values for any data set, regardless of the size of the data set, would fall within one standard deviation of the mean. Remember, the mean is your measure of center. Okay, and so if we go one standard deviation below and one standard deviation above, we should have approximately 68% of the data. If we go two standard deviations above the mean and two standard deviations below the mean, you should have a total of 95% of all the data values. And then finally, if you go three standard deviations, you'll have 99.7% of the data values. And so I think most of you seem to understand the numbers, but you seem to be struggling with how to apply this. So let's take a look at some questions. I pulled some that are similar to the ones you had in the lesson for measures of spread, but I've changed the numbers. So a couple of things we want to think about. It says in a bell-shaped data set. Okay, first off, the fact that it talks about a bell-shaped data set lets me know right off the bat that I can apply the empirical rule. If it is not a bell-shaped distribution, then you want to use Chebyshev's inequality. Furthermore, it tells me that my data set has a mean of 70 and a standard, and approximately 68% of the data are between 60 and 80. So it may help you to kind of visualize what's going on here. So we have a bell-shaped distribution. The mean, which is the measure of center, is 70. And then it gives us two values. It gives us a low value and a high value. And it tells us that there are approximately 68% of the data between them. So you have 60 and 80. And we're told in the story or in the problem that approximately 68% of the data values fall in that particular interval. So knowing that it's a bell-shaped data set, which means I can apply the empirical rule, and that approximately 68% are between 60 and 80, I have to remember that at 68% is the percentage that corresponds to one standard deviation. Okay, so formula-wise, this would be 80 would be the mean plus one standard deviation. 60 would be the mean minus one standard deviation. The empirical rule says that approximately 68% of the data fall within one standard deviation. So I can then set up a very basic equation and solve it to determine ultimately the standard deviation. So I have the mean minus the standard deviation is going to equal 60. But I know that the mean is 70 because that's given to me in the problem. So I have 70 minus the standard deviation is equal to 60. And I'm going to solve that particular equation, good old basic math, for sigma, or for the standard deviation. Negative 70, subtract 70 from either side. So I have the opposite of the standard deviation equals negative 10. And then I'm going to divide both sides by negative 1 so that the sigma is equal to 10. Now, if you're getting hung up on the notations, okay, you're going to have to get familiar with this, but the nice thing about it is, in statistics, once we define a symbol, that symbol means the same thing every time, all the time. So this funky looking U is actually the Greek letter mu, and it represents the population mean. And this little funky looking O is the Greek letter sigma, and it always represents the population standard deviation. Now, just to verify that I'm correct, we looked at the lower end, but we could also, or instead of, we could have calculated using the high value. So we could have considered the mean plus sigma, and that would equal 80. And again, we know that the mean is 70, so we'd have 70 plus sigma equals 80. And again, if you solve that good old basic algebra equation, I should get the same answer again. But let's just double check ourselves. Okay, so I'm going to subtract 70. So sigma is 10. See, I got the same answer. So ultimately, the answer, I want to know what is the standard deviation. The standard deviation here is 10. All right, here's the next question. The GMAC Insurance Company reported that the mean score on the National Driver's Test was 75.2 with a standard deviation of 3.4 points. The test scores are approximately bell-shaped. Approximately 68% of all test scores were between two values, and they refer to them as A and B. And then you're asked, what is the value of A? So a couple of things here. Again, you want to be kind of careful as you're reading through the problem. It may help you to highlight, to underline things. Again, first off, I noticed that it tells me that my test scores are approximately bell-shaped. And again, knowing that it's bell-shaped is my clue that I can apply the empirical rule. Secondly, in this problem, it also says approximately 68%. And we just talked about it, that approximately 68% are within one standard deviation of the mean. Now, this problem is different because they don't tell you what those cutoffs are, but they do tell you what the mean and the standard deviation are for the problem. And again, it may help you to look at a picture of what's going on. So I would have a bell-shaped distribution. My mean, which is the measure of center, is 75.2. That's given to me in the problem. Mean score, 75.2. And then I'm also told, and I'm going to kind of put this one off to the side, that the standard deviation is 3.4. And I'm interested in knowing, the values of A and B. So we have a value that is one standard deviation below the mean, and we have a second value, which is the mean plus one standard deviation. And we're doing one standard deviation because it says approximately 68%. So honestly, again, at that point, it almost becomes reasonably straightforward, and you're going to do kind of what I call plug and chug, okay, because you're going to use the formula. You want to ultimately know what is the value of A, and A was my lower value, so I want to calculate the mean minus one standard deviation. My mean was given as 75.2, my standard deviation as 3.4. So I'm going to do that subtraction. I'm going to use my handheld calculator. So I have 75.2 minus 3.4, which gives me 71.8. So this low value here for this particular data set would be 71.8. Now, I'm not asked to, but I could also calculate B, but it doesn't ask me for that. All right, so let's move on to the next one. Again, a lot of this is going to require you to maybe read carefully, use a highlighter. Notice that I'm using different colors to do things. That may be helpful to you to use different colors, but you need to read slowly and carefully. So this one reads, in a large sample of customer accounts, a utility company determined the average number of days between when a bill was sent out and when the payment was made is 22, with a standard deviation of 18 days. Assume the data to be approximately bell-shaped. Approximately 95% of all customer accounts have the average number of days between two values A and B. What is the value of B? Okay, so here again, when I'm looking at this, one of the first things that I want to kind of think about is it says approximately bell-shaped. And again, knowing that it's approximately bell-shaped is my clue that I can apply the empirical rule. The second thing that I notice is it says approximately 95%. And so I have to think about the empirical rule. 95% says that I'm within two standard deviations of the mean. And I'm told the mean is 22 in the problem and the standard deviation is 18. And again, it may help you to visualize what's going on. So if I draw a picture here, I have my bell-shaped distribution. My mean is in the middle, which I'm told is 22. Okay. And I want to know approximately 95%, which means I'm within two standard deviations. So I have some value A that would be the mean minus two standard deviations. And I also have a second value B, which would be the mean plus two standard deviations. And again, I'm using two standard deviations because it had said approximately 95%. In this problem, it asked me to determine the value of B. Okay, that's the question. What is the value of B? So B corresponds to the mean plus two standard deviations. So using the numbers that I'm given, the mean is 22 plus 2 times the standard deviation, which was 18. Okay, so I have 22 plus 2 times 18 is 36, and 36 plus 22 is 58. So the value of B would be 58 days. All right. One more, but it's got 3 parts. It says a sample of 50 students were asked how long it takes for them to travel to campus. The mean travel time was 28.6 minutes with a standard deviation of 4.9. Assumed travel times are approximately bell-shaped between what two values will about 68% of the data lie. So again, right off the bat, it tells me approximately bell-shaped, which means I can apply the empirical rule. The second thing that I notice is it wants to know what two values will about 68% lie between. Okay, remember 68% corresponds to 1 standard deviation. So again, if we visualize what's going on here, we have our bell-shaped distribution. The mean is in the middle, which I'm told is 28.6. I also know that the standard deviation is 4.9, and it wants to know what two values. So I'm going to have one value, and we can continue to call them A and B. So you have value A, which would be the mean minus 1 standard deviation, and you have the value B, which is the mean plus 1 standard deviation. And in this problem, you basically got to find both values. So if we start with letter A, and it really doesn't matter which one you start with, okay, we would have the mean minus the standard deviation. So we would have 28.6 minus 4.9. I'm going to get my calculator. Okay, 28.6 minus 4.9 is 23.7. So in this case, letter A, as we're calling it, would be 23.7. I then need to also calculate B. So I got to do the mean plus the standard deviation. So I'm going to do 28.6 plus 4.9. Use my calculator. Guys, please learn to use the calculator. Don't try to do these calculations in your head. So it's 33.5. So to answer the question, approximately 68% of the data would lie between 23.7 minutes and 33.5 minutes. Now, using that same scenario, the next question asks us, again, they tell us it's bell-shaped, but now they want to know between or about 95%. And so we have to remember that with 95%, that is 2 standard deviations. Okay, oops, sorry about that. Let me scroll back down. Okay, so again, it may help you to visualize it by drawing the picture. So we're going to draw the picture again. You have your bell-shaped distribution. The mean is in the middle, which was 28.6. And again, we're looking for basically those kind of cutoff values. Okay, in this case, again, we can call them A and B, but A this time is going to be the mean minus 2 standard deviations, and B is going to be the mean plus 2 standard deviations. And again, we're using 2 standard deviations because the question alludes to about 95%. So using the two formulas, you have the mean minus 2 standard deviation. The mean is 28.6 And 2 times, and the standard deviation, let me make sure I remember it correctly, is 4.9. Okay, so it's 4.9. So you're going to have 2 times 4.9. Whoops. Now, you guys, you got to be careful because you do have to follow order of operations here. Okay, and so if you're following order of operations, in this particular case, you need to multiply 2 times 4.9 first, which gives you 9.8. So you're going to have 28.6 minus 9.8. So using my calculator, I get 18.8. Then I need to calculate the mean plus 2 standard deviations to get the high value. We would have the mean is 28.6 plus 2 times 4.9. So I have 28.6 plus 9.8 is 38.4. So approximately 95% of the data would lie between 18.8 and 38.4. And finally, if we look at the last one, same problem, but this time, they still tell us it's approximately bell-shaped. We want to do approximately or about 99.7%, which is 3 lie within 3 standard deviations of the mean. So again, visually, what you're going to have, you'll have your bell-shaped curve with your mean in the middle, which is 28.6. And again, you're looking for those cutoff values. You're going to be the mean minus 3 standard deviations, and the mean plus 3 standard deviations. And so again, we use the numbers that we know. We're going to kind of plug and chug and get those values. We have the mean minus 3 standard deviations. The mean is 28.6 minus 3 times the standard deviation of 0.9. Now, remember, you need to do that multiplication first, 14.7. So we have 28.6 minus 14.7. We get 13.9. And then we also have to do the high end. Okay, so we would have the mean plus 3 standard deviations. So that's 28.6 plus 3 times 4.9. That's 28.6 plus 14.7. That gives me 43.3. So about approximately 99.7% of the data would lie between 13.9 and 43.3. I hope this video has helped you to kind of get a better grasp and understanding of the empirical rule. And so that'll finish us up.